Okay, we've got one more thing to deal with in terms of everything we've been looking at with the service workers and the sub-processes and that sort of thing. And that's to do with the fact that when I first introduced these service workers, I mentioned they're quite commonly used for Windows services. Now, we didn't go down that path because it was better for the application we were looking at to use a sub-process. But this week, I thought I'd show you how to set up this idea of a Windows service. Now, this is not the best solution for the problem we're looking at. That's why I went down the sub-process path. But I don't want to switch to a completely different example. So we'll look at how to set this up as a Windows service, and then I'll explain why it's not quite as good as the way we did it. Let's just have a quick reminder of what we've got. So remember what we have here. If I run this up, we get the MVC and JavaScript based window. We also get the WPF window. I can enter a name in this one, enter the game, and then in here I could go for Sally, and the two of them can play against each other, and we can see how that all works. And remember that the way that works, because this is a framework WPF application, we've got this sub-process written in core to connect to the core SignalR server. But let's now switch that to the idea of running not as a sub-process, but as a Windows service. And to start with, let's just make it run not as a Windows service, but just as a separate standalone application. Because it's generally good practice to get the thing working just as a regular program before you tackle the issues which slightly complicate things of making it a Windows service. So let's do that. So what I'm going to do is, firstly, I'm going to change that dependency that I created a while ago. And so now we're not going to be building the SignalR worker from the framework client. And then we'll also go to that framework client and look in this worker service proxy. And remember, this is where we kicked off the sub-process. So I'm going to delete that worker service, and then there'll be lots of other things that we can get rid of in terms of all that, because all of that is going. We're going to assume that this worker service is already running, initially just as a standalone application, but then ultimately as a Windows service. So that all looks okay there. If we then go to the actual worker, well, what I'm going to do is open this up in a separate instance of Visual Studio, because I want to treat these as separate things now. So I'll just drag that over. Normally I'll be developing these on separate screens, but we've got to do it on the one screen here, so it's a bit confusing. But what I'm going to do is go to that SignalR worker, and if we go to the program, because we're not being launched as a sub-process, we're not going to have this in pipe and out pipe, so get rid of those and get rid of them being passed in there. In fact, we'll change this back to just injecting the worker with its default constructor. So that's what we'll have like that. Let's go to the worker, and again, we're going to have to get rid of that in pipe and out pipe because we don't have that information. And that leaves us with a problem. How can we get the information from the WPF client to this worker service as to what the pipes are? Well, the fact is we can't do that with this idea of an anonymous pipe. We've got to switch to a named pipe, and basically both halves of the system, the WPF and this application here, have got to agree on a name, and that's how it's all going to work. That gives us a slight advantage though, because as it stands with the anonymous pipes, they're not bidirectional. That's why we've got two pipes there, one for the data coming in, one for the data going out. But we can, with these named pipes, we can make that bidirectional, so we only actually need the one of them. Another thing to notice is actually we're going to have to reverse the idea of the client and the server, because at the moment you can see on the worker service this is the anonymous pipe client. The reason being that it's the WPF application that's created first, and that's why that counts as the server, and this was created second. But now we're turning this into a Windows service. This is going to exist first, and the WPF application is going to exist second, so this has to be the server. So a few changes we're going to make there. We're going to get rid of the original anonymous pipes, and we're going to replace that with a private read-only, and then this is going to be a named pipe server stream, and we're just going to call that pipe stream. And as I say, no separate in or out, because this one can be bidirectional. And then again, get rid of them in here, but we can then replace that by saying pipe stream equals, and then we just go for a new named pipe server stream, and then we give it a name. So this is the thing that has to be agreed between the client and the server. So I'm going to just call this RPS pipe, rock, paper, scissors, pipe. And then a few bits of configuration, make it bidirectional. So we have the pipe direction of in, out, which was the one that, although it was available, it didn't actually work with the anonymous pipes. And then the next parameter we're going to have is going to be the maximum number of server instances. We're just going to have one of those. Then a thing called the transmission mode. Now, This can be either byte or message. Byte is normally there if you're going to have a continuous stream of data. Message is more appropriate to what we're doing here. And then the final thing we need to have on these pipe options, we need to make that asynchronous, basically so we can have continual two-way communication without any blocking. So that has set up our pipe. And then, because it's bidirectional, we can use that for both the stream writer and the stream reader. That will read both ways. Now actually, we're going to need to do a little bit more here because we need to do some asynchronous configuration. So what I'm going to do is put in a private task that I'll call configure. And I'm going to grab a load of the code we put in here. Basically, I'm going to take all of that and pop it into the configure. But actually, I'm going to put back just that creation of the hub connection. So we're going to create the stream and the hub connection in the constructor, but we're not going to do anything with them. And then also going to make these two nullable. We're going to have to put async on there. And then a few places we're just going to have to check for null. So we'll question mark in there and a question mark on there and on there. And again, replace the pipe in and pipe out with just our pipe stream. And so all that should now be looking fairly happy, except we haven't called configure, and we do that at the very beginning of the execute async. So here I'm going to put an await configure, and also let's put that hub connection start in here as well. But then the other thing I have to add before we do any of that, which is why I moved it, we're going to in here do an await, and then on that pipe stream we're going to do a wait for connection async. So because this is the server, it's going to start up, it'll get to that point, and then it sits and waits for our WF application to come along and connect to it. So that should have got all of that working. Just one little thing to notice, we are getting a warning on that message mode because, as it said, that's only supported on Windows. So we're not going to be writing portable code here anymore. But we know that because this is a Windows service, so it's got to be something that only works on Windows. So that's not going to be an issue. Okay, so that's our server working okay. And we can see that's working. If I just put a break on that wait for connection async, and then also set this so only the signal worker is going to be starting up. And then if we run that up, we can see it brings up the console. There's nothing in there. We've hit that wait for connection async, and then if I step over that, it just stops and waits. Nothing's going to happen until we get the client, the WF, connected. So let's take a look at that now. So let's go to our other Visual Studio and start making the changes we need here, which is in our worker service proxy. So we've already got rid of the launch of the process, but the other thing we need to do in here is we need to switch once again to using the named pipe. So we're going to get rid of those two anonymous pipes and then put in here a private, and then here a named pipe client stream, because remember this is now the client. Call that pipe stream again. And then in our dispose, let's just replace that with just the pipe stream, and then get rid of all of that. Here we're going to say underscore pipe stream equals new named pipe client stream. And then first thing I've got to put in here, that dot just means the server is on the current machine. So we can use these named pipes for cross-machine communication, but we don't need that here. So we just put a dot in there. Here is where we make sure the name is the same. So that's RPS pipe. And then pretty much the same sort of thing. In here, we're going to be putting our pipe direction of in out and our pipe options of asynchronous. And that should give us a connection back to the pipe. We can then use that for the stream reader on the stream in and the stream out that we've got there. And apart from that, that should be pretty much the same as we had before. One other thing we've got to do though is just like we had the waiting to connect on the server side, on here we do a pipe stream dot connect. So that's what makes the connection, should make it all work. So if we run this one up, then we've got the various windows launching as we saw before. But if we go back to the server, just ignore that for now, but you can see we've gone over that wait for connection. So it's picked up there's been a connection and everything else should then start running. And so now on the WPF, I can put in Harry, click enter. You can see it's made the connection because that, remember, comes back from the signal R. And then if we do the same sort of thing on the MVC, there you can see we can start playing and we've got the results working. So that's all working now with the worker service running as just a standalone application, not running as a sub-process, and we made those changes to get the named pipes to work. Now we need to turn that into a service so that we don't have to run it up every time. So let's close all of that down, and in order to register this as a service, what we need to do is bring up a command prompt, but it's got to be running as admin. So let's run the command prompt as administrator. And then the command we need here is SC for service controller, and then create, and then the name that we want to give it, which is going to be signal our service, let's call it, and then the path to where we're going to find the executable. So we have bin path equals, and then let's just drill down in here. So in File Explorer, drag that over and then go down into bin, debug, .NET 9, get hold of that and paste it in there. And then finally, it's going to be signal our worker.exe. And if we do that, we can see it successfully created the service. And so now all we should need to do is come into here. We'll go to the service manager. We could do this all at the command line, but it's easier once it's registered to come in here. And if we scroll down, there we can see we've got our signal, our service on manual startup. So let's start it. And immediately we hit a problem. You can see that looks like it's loading, but then it gets about halfway and it really slows down, because the problem is, although we've written this as a worker service and it's registered fine as a Windows service and it looks like it's working, we've missed out one vital piece of the jigsaw, which is how the service manager communicates with the service. So eventually you're going to see this is going to give up, and then as we see there, we can fix that very simply. So what we've got to do is go back to our application and add in a little bit of NuGet. So let's go in there, we go for hosting dot WindowsService, put that in there. So this is the extra package we need beyond what you normally get with your worker service. So we apply that, and then in the program, all we need to do is in here, we just add builder.services, and then what's coming from that package, add Windows service. So that makes this a Windows service. That means that it can communicate with the service manager to tell it it's started up, to be shut down, that sort of thing. And then the other thing we can give it on those options, we can just say dot service name equals, and basically this is what is going to be used for any logging. We're not really looking at logging, but it hooks it up to the Windows event log, and that's the name it will use for the source of the event. So that should get that all working. And so if we just build that, we don't need to re-register because we've registered to look at that executable, and when the executable updates, it will just pick up the latest one. But now we should see when we start that signal our service, it should get through much quicker, and now we can see we've got that up and running. So simple as that, but one extra thing you've got to do to turn a worker service into a Windows service. Now let's try to connect to that. So now let's go back to our client, the WPF, and run that up. And you might think everything would work fine, but you can see immediately we get an error when we try to connect to that pipe stream, because things running as Windows services are running in a different account with different security levels. We saw how we had to be administrator to get in there at all, and that's the problem it's got. We've got that access to the path is denied. So let's fix that. So I'm going to stop that, and we actually need to make some changes on the service, and let's go into our worker and find the place where we were setting all of this up, which was up here. And in fact, we've got to do a bit more work to allow access from other processes. So what we're doing here, we're going to say var sid equals new and then security identifier. And then pretty simple what we can do there. We give it a well-known SID type of world SID and then null for that domain. So very simple security there. Then we have another one. We say var, and we'll call this pipe security equals new pipe security. This one we just create with the default constructor, but then we do a pipe security dot set access rule, which is a new pipe access rule. And then for parameters, that takes the SID, then we give just full access. So I'm not being really at all secure here, but just to get it running really. So we'll have full control on there. Then we'll have access control type, just get hold of the namespace for that, and that's going to be an access control type of allow. And so that should be everything okay. Once again, you'll notice we're getting warnings. Same warning we had before, that this is only going to work on Windows, but as I said, that's going to be fine. And then a little bit of an oddity, we can't actually pass this pipe security into the pipe stream via the constructor. We have to use a factory to do this. So there is a factory available that's called named pipe service stream, and then ACL for access control list, and that has a method called create, and you can see that takes mostly the same parameters, but we've got to put in, after that asynchronous, we put in a couple of buffer sizes, which doesn't really matter for what we're doing, so I'll set them both to 0. But then as the final parameter, we put in that pipe security, and again, lots of warnings, all for the same reason, but that should now be enough to make that work. So what we'll then have to do, let's go back to our service manager, let's stop that, and then we'll rebuild the service and then go back and start it again. And now let's rerun the client. And now that seems to be up and running okay. Let's try entering Harry. Click enter and we get a different exception this time saying that the pipe is broken. In fact, if we look at the service manager, although it's not very informative there, if we right click and look at properties, we can see that the service has stopped. So what's happened now is we've hit an exception in the service. I hadn't put any exception handling in there, and so it's just died. So what we've got to do, obviously, is we need to debug it. And we know how to do that, or at least we think we know, because all we've got to do is back in the program here, let's just put that debugger.launch back in that we were using before when we had it as a subprocess, build that once again, go back to the service manager and then start it again, just drag that over. Immediately you can see we're getting the normal thing, but then we get a bit of an oddity. You can see that although I've actually got 2 existing instances of Visual Studio running, it's offering me a new one. And remember, that's not much use because it hasn't loaded the project, so we can't see all of the source code. The reason that it's done it like that is because of the level of authorization within the account. The 2 versions I've been running of Visual Studio have just been running in my local account, but in order to debug a Windows service, they've got to be at the admin level. So what I've got to do is go to the one that we're editing the service in, close that down, and then let's get hold of Visual Studio again. But this time I'm going to run that as admin. And then again go for Signal R, but you can now see in the top right hand corner there, it's saying admin. And now, when we try to start the service, yes in there, and now you can see that it's offering us that administrator, so we'll accept that, and then we've got the normal debugging process that we can go through. So let's just go that, and now that's up and running and it's debugging. We haven't hit the problem yet, we only hit the problem, remember, when in the client application we actually tried to do something. So now if I type Harry in there and click enter, now we can see we've broken in the service, and basically it's telling us we've got trouble with the security now on the Signal R connection. So if we just look down here, you can see through the call stack in here, it's when we're trying to do that start async. And the problem is, again, because it's running within this high security environment of the Windows service, it can't recognize the certificate that we've got on the server. So last thing I've got to do is fix that as well. So what I'm going to do is let's just stop the client, come back in there later, but some more work on now the hub connection to make that secure as well. So what I've got to do here is on that with URL, I've got to add some options in here. And again, this is not going to be super secure. It's just going to be enough to get it running. But what I'm going to do, I'm going to say options.http message handler factory. And we set up this factory to be another lambda. So we say equals message and then arrow. And then in here, we say if message is and then HTTP client handler, and if it is, we just call that client handler, and then simply enough we say client handler dot server certificate custom validation callback. So this is the callback that gets called when it's requesting certificate validation, and we're going to basically completely bypass all of that. Don't really care about the parameters here, so I'll just put in 4 discards. and then simply return true. So always going to approve, which is a bit ugly, but it'll get the thing working. And then we also have to return here the message itself, so it can be chained on to the next thing it's doing. Just need to put a semicolon on there, and then that should all be happy, and so it will now accept the invalid certificate coming in from the SignalR hub. And so if we now rebuild that and then go back to the service and start that one up again, this time I'm not going to bother with debugging because I'm fairly confident it's going to work. So that's all up and running. Then let's go back to the client and run that up. So there we've got the MVC site, and there we've got the rock, paper, scissors. And so let's put in Harry in there, enter that, that's got the message back, put Sally in there, enter that, and then we can start playing the game as we did before. So that's all that working. We've got the Windows service. We had a lot of fiddling around to do that because of security issues, getting it installed in there, debugging it slightly differently. And that's certainly one set of reasons why doing the sub-process was much easier. But the key reason is that when we had the sub-process, we would have one sub-process per WPF client. So if we wanted to run multiple WPF applications on the same machine, they'd each manage their own sub-process, which would then connect to the SignalR hub. But if we did it through the Windows service, we've only got one instance of the Windows service, and therefore, as it stands, it wouldn't allow multiple WPF clients. We could have done some coding in there so that the Windows service knew which of the WPF clients to send messages back from the hub to. So it would have been possible, but it would be another level of complication. That's why it seems much simpler to do it as this idea of a sub-process. So that was just rounding that part of it off, showing you this as a Windows service. I hope you enjoyed that. If you did, do click the like button, do subscribe, and I'll see you next time.